expect in order to be seen.
Did you plug in the power?
Yes, that's the first question.
Yes, sir.
Good afternoon, everybody. Welcome to RIFT afternoon session. We are looking for a note taker. You know, it would be really great. It's your first time. If you take notes, you remember what we talked about. Would you be able to take notes, please? Would you be able to take notes? Thank you. Can anyone take Jabber, please? Silence. I'll try to get to Jabber. Please read not well. It changes from time to time, so it would be good if you read and see the updates. You know what everything you say and do here is IETF property, and you should know the rules of IETF.
Okay, so we'll start with our agenda. We have a full agenda, so we'll just get to it now. Admin staff, the first base specification status, we have published the 03 revision. The PGP and segment routing stuff were moved out to 2 separate drafts, and so some other progresses that Tony will talk about. There is also ongoing open source implementation. Tony will also provide an update on that. And then on the milestone part, our original goal was to submit the base spec to IESG in February 2019. I think now we probably need to push it to the summertime, July or June, I forgot. It's done. Alvaro, do you have any comment on that? It's okay if you don't. Just one. All right. Okay. And about the supporting documents, we have the Young specification going on. The applicability statement and threat analysis documents, which were required in our charter, they need to be written. So if anyone can help, we'd appreciate. And the PGP and SR drafts that were separated out, they are on the side burner now, but we do have that skeleton draft there. Comments and contributions are welcome. I think that's the admin part. Do you have any?
Yeah. So yeah, if you're interested in participating in segment routing work, and we are doing it quite different than what you see in SPF and SAS, it's a pretty interesting exercise. Please join us.
So is anyone recording this session? Because we don't ask for a recording. Sure. You guys have something? Not really?
This session, yeah, it's recorded by me to go, so just make sure you speak in the microphone and stand in the box. And you should find yourself.
I don't. Okay.
Do you see me now? Okay. Yeah, all right, cool. All right, so now in the middle of the road, the crowd is getting smaller, still bigger than early OSPF sessions, I remember. So that's the update on the 03 draft, which is pretty much all the work we did between 02 and 03, so between the last IETFs. Tons of authors got added, so I just pushed it all on a separate page. We call this whole thing the Rift authors, and I'll fight, whatever the publication process will be. All right, so the last one we've shown was the 02, 3 out for evolving. Tons of specification. I give you some stats just to emphasize the volume of work. Not much was happening on the big list, which I'll talk about quickly. Tons of open source code has been written. We interrupt the stuff, learned lessons. So I'll talk about that stuff extensively. Some of them, entertaining, some insightful, some plain stupidity, as it goes with software. And we had these once and twice weekly meetings, which were partially recorded. I was sending the stuff out to the list. Nothing secret about that stuff, but it's basically a hardcore crowd, which is 6 to 8 people showing up and chewing, through all the details. All right, so what's the status? Why is this thing not coming up properly? So now that's the marketing geek, right? So where were we in the 2? Yeah, all these colors look wrong. Look there, that's the colors. Okay, this thing is all wrong. So we were pretty much nowhere with the security envelope, and the flooding FSM wasn't well specified. It was like wave, IS. We didn't have anything on the Malta plane spine, which is a difficult problem, but a real problem. And that is pretty much, a very big addition on the 03, and Pascal will talk about the stuff extensively. We chewed through a couple of design options that is actually extremely interesting corner of the world. But again, most of the customers run a single plane, so somewhat ephemeral. What else was missing? I tried to read the stuff. Yeah, so we talk about moving from the hull concept to like best available level that died on the wine. It's actually extremely simple to, loop things like ZTP. direct implementation experience. So that didn't happen. Right, and the rest was in a fairly good shape. So where did we end up on the 0.3? More green. Green's good, right? So the security envelope is still being chewed, and I think I'll call for a meeting with possibly Alvaro and AC, because it is not entirely clear what should be the security model. We can go to private key, no private public key. We can go to shared secret. Opinions vary. People have different ideas what security on IP fabric means. So that's still under work, but the envelope starts to gel, because we talked about things like, nonce exchanges, so to secure the stuff properly compared to today's routing protocols. All this stuff is kind of green by now. So we have the full multiplane spine. We have the negative transitive disaggregation, positive disaggregation. We have the full flooding FSM in excruciating detail, minus one thing I'll talk about, which is, I'll probably not explain in a lot of detail because that's ongoing work. We found something interesting on the lie FSM, which we still have to add. It's nothing particular well understood, has to be done. ZTP was all stabilized, mobility, BFT, bandwidth balancing, optimal flooding reduction. That was well stabilized. Actually, there are better ideas now for flooding reduction, and I refuse to take them on. Pascal always improves on himself, right? But we have to, at a certain point in time, get finished. All right, so tons of stuff green. Really, security is the only interesting stuff we're chewing. Like I said, I'll be putting AC probably and Alvaro in, because it is more of an architectural discussion, what makes sense, rather than, how to do it. How to do it, I think, is fairly well understood. Good. So rough statistics, because people may have perceived it slightly quiet. So most of the discussion happened between like 10 people on like a core mailing list, where things percolate in a very tight cycles and on the weekly meetings. So I just look at how many emails flew between the last IETF and this IETF, somewhere to the order of 300, 400 emails, and pretty much weekly, sometimes bi-weekly when it got really hot, right? And people got really interesting, and we pushed a lot of envelopes, nothing that has been done before. So a lot of ideas have been scrapped and reinvented and so on, right? We had about 255 commits just on an open source base, and that's without the merges. I think we have 7, 8 branches, and stuff is being pushed up. To give you a feeling for the patch, it's probably like a 16,000 lines patch, whatever that means. Just tons of code, right? And the spec changed by 6,000 lines if you look at the diff. So lots of work has been done there as well. Mainly flooding procedures, multiplane fabric, and tons of small fry, because we were operating the code. I mean, not on a weekly basis, but every 2-3 weeks, we would bang the code against each other, which I won't even talk. Bruno's framework, open source framework he came up with, is one of the cleanest frameworks actually to teach a protocol, both building, how do you analyze the protocol behavior, how you debug it. So it's very easy to pull in, the unnamed vendor's code and Bruno's code and run the stuff just up the hill. Within a couple of minutes, we get like a full interop. There's lots of, all the logs, graphs, and so on. So lots of stuff can be shaken out. I'll talk a little bit farther. A little bit farther down the road, I give you an update what Bruno did, because he's on his walkabout for like 2 weeks, crawling up some mountain, trying to get eaten by a bear or something. Then I'll be back and writing code day and night. Yeah, that's how it goes. On the other hand, the interesting thing is that the model has stabilized largely. So we only changed like 7 objects on the model to give you like a feel, right? So the encoding isn't changing much. We exchange pretty much all the information that we need to get the stuff done. It is more like, how do we chew the information properly? Ideas discussed and scrapped. That's the most fun part, right? It never got boring. Did we have a boring meeting? I don't think so. Right. Yeah. So that's what sucked people back in, because tons of interesting stuff. We were really pushing the curve in many respects. So we removed tons of stuff, right? There's the 7,000 lines. good chunk is removed. And that comes from like customer iteration, looking what would be really useful, which mechanisms are old style, not even needed anymore. So we checked out the whole PGP. There doesn't seem to be any demand or any realistic way to do traffic engineering on fabrics. No, that's just my gut feeling. So the PGP went in a separate draft. We preserve it, we drag it along, may prove useful. It's a nice mechanism. The segment routing stuff got checked out into separate draft because there's multiple model how you do segment routing on a fabric if you choose to, right? Like distributing the labels and what you can do with the stuff and so on. It just didn't seem to be the baseline of the spec. The information is carried on the encoding model, but the procedures and how you get all these labels, what you do with them, didn't seem like, the right, it just diluted the spec. The key value store will go into its own draft. It actually looks that the key value store will probably need something like a registry because there will be some well-known keys, there will be some vendor keys, this kind of stuff. So that should probably go off into its own draft, like also the well-known uses for a key value store and some kind of a registry. So people don't, do the same thing in different forms. We get some interoperable, well-known stuff, and on the other hand, the vendors have basically a nice playing field, some OUI kind of stuff. All right, so what is it we do except removing stuff and having fun? First, of course, we had to change the language. What fun is a spec where the glossary didn't change? So when we talk things through, it became clear that actually the top of the fabric is a very important concept if you run multi-plane fabric and you want to run them through this kind of protocol. Anything between the leaf and the top of fabric, it's actually not particularly special, so we call it spine now, and the top of pod sometimes is useful in a language, right? That's where the pod stops and you start to go into basically building your spine. And we talked about the radix because that is a very central concept when you start to build multi-plane fabrics, because multi-plane fabrics happen when you basically run out of radix. So you have to break up your fabric into multiple crossbars that are hooked up by crossbars, which are not all really one crossbar. So we have like a whole pictorial. One of the really fun parts was to squeeze a picture of these multi-dimensional fabrics into some kind of a two-dimensional representation, which actually clarified a lot of thinking, right? Like the mortal danger and ASCII format beautifully, concentrates your mind. Now, this is interesting. So Bruno implemented the whole flooding, and he implemented it cold. We like it that way, clean room kind of stuff. And most of the stuff he could derive just by common sense, looking maybe at an ISIS spec once or twice, and probably just being good at it. So the flooding implementation has been done clean room. We didn't talk up front, right? And he started to come up with clarifying questions. And his answers were mostly right, but the fact that he had to ask the question indicated that the spec wasn't tight enough, right? So the scope table is now, in a sense, do I have something red? Oh, yeah, cool. Look, okay. So this became far more clear. We actually spent good amount of time of tightening up the language. And one of the sloppy language cases was leading to a flood oscillation. Nothing major, but something that never stopped the flooding, converged to flooding, okay? And because we understood that the top of fabric is actually an utterly different beast, if you deal with multi-plane fabrics, the flooding scope also broke up into more elements. So there is a difference when you have a tire as a request and the tire as an X in the scoping. Right. The most interesting part probably that the east-west scoping became not like, oh, it's just like any north link. When you low in the fabric, you want to use east-west links as kind of the last resort to get to the top of the fabric. Once you're at the top of the fabric, the whole game actually reverses. So your east-west link becomes south links. That's how you get down to through the fabric. If you can go directly down, you just push it east-west to your neighbor who can actually get you down. And that reflects in the flooding scopes. And I will not chew that stuff to pieces, but it's more detailed, tighter. A couple of things became much clearer after Bruno implemented the stuff and interrupted, right? I mean, I knew what I was doing, right? No hands, always root password, right? And Bruno, when he derived that, he found these one or two things where we were just too, too loosey. So that was the second one. I thought I'm going like a steam train, okay. So what did we do? Third, we wrote all the flooding rules in excruciating details and shoot them through in the appendix B3 about some people complain it's way too complex, who didn't have any beef with implementation actually. So I asked them what they even read the stuff, okay. I think this is the clearest write down of flooding you can do, but of course, and John Moy was already high bar to pass. And it basically breaks down to a couple of queue manipulation. You have 4 queues, which is ties transmit, ties retransmit, request, and ACK. And then what fell out when we started to write down these rules, and Bruno started to look at my implementation. So the tie generation, CS&P, translate real time, OSPF has none. You basically periodically dump out your database, break out the description of your database's header, and you dump it out. And when we found out that there is something called the min and the max, so at the end you indicate I'm starting and I'm finished, and that's the last one. And that wasn't tight enough. It wasn't spec'd out. So he was sending a different min, I was sending a different min. It just worked, but we both got confused. He actually managed my application to go like, what the hell is this guy sending? Because he was sending something that looked like a reasonable mean tie, and I expect something which is really not a valid mean tie. The included lifetime wasn't specified tight enough. That's a 0. So he went to the ISI spec and he did the right thing, and it worked. We were lucky. So a couple of things got fixed by looking slavishly at the ISI spec. And then it was very interesting. Bruno was kind of like, why the hell is flooding done that way? So why would you sort the headers? And he had a bunch of ideas, we shoot threw them all away. ISI is very hard to improve on in this respect. The processing, what did we find? He found a major bug, which was the 17th clause of the 4th subclause of the 17th thing in ISIs. I forgot that they bolted on. So when there was a loop in the, there was a hole in the tide, I didn't check whether there's a hole, and I have actually to send those things, request them. So I didn't. So the flooding is so positively robust, especially ISIS, this whole thing was working, which was largely by accident, belts and suspender. So we found that. Excellent outcome. And there was a super delicate bug where I have wrote in the spec larger equal, and it was really a larger, which was showing in the corner case. Tires. So on a generic basis, you just take all the requests and the X that you have on your queues, and you just push them out. Didn't find any issues. On the type processing, we didn't find anything either. All right. And then what did we do then? We actually went into the whole multi-plan fabric, which is a fascinating topic. And Pascal will be chewing the stuff to pieces because he came up with a lot of this methodology, pictures, and so on. But of course, I have to give you like a retro picture, right? And the red rings will become clear, and the whole, So the idea is that you have 2 planes at the top. So you see those switches are connected to each of the plane, and this switch is connected to the other of the plane, but you are breaking those 2 guys in a different plane at the top and those 2 guys into a different plane at the top. All right, and that's largely caused by, radix. You just run out of radix when you go size. So it's nothing recommended until you can do it otherwise. But if you get there, you get there, and you have to deal with it. And we're working on the secure envelope. lots of interesting stuff there. Okay, so the link state protocols kind of like bolted on the security, and they found all kind of interesting problems, like, and they kind of walked around a couple of problems. So you do all kind of checksumming, but you leave off certain fields like lifetime, which leaves you open to attacks, which led to another draft. We were also looking for an envelope. So once you start to work with the model, you find out that you don't really want to deserialize a model. You want to treat it as a blob, because you can't just go into a field and just muck around with it. You don't know what the offset is. The model will not tell you. And if you deserialize and serialize, you may end up with the semantically same packet, but with a completely different binary representation. There's a lot of cases like that, right? So if you want to authenticate this stuff as a binary blob, you better never deserialize, serialize again, because you never know what you end up with. So the stuff you can muck around with, you really want to pull out the packet. And then there is a bunch of things which we don't do particularly well today, which is something like non-sys. So when we establish an adjacency, we really build security association, which gives us integrity, but it does not give us privacy. So that's kind of a particular thing, right? It leads to the discussion, should we even go into encryption on link or on routing association? But even without that, once you get that, you can protect against flooding, replay attacks, and all kind of stuff. So SPF has some of the stuff, but we try to make it somewhat cleaner and better. Les, you're welcome. Fascinating discussion. Greenfield. We can do what we want. We don't have to count the bytes, okay? All right. Let's forget all the stuff. And really the big discussion, should we go to a private public key model, or should we keep it a shared key model or shared key per interface model? That actually has a lot of impact, how you build this stuff. And I don't have a clear answer. I see people being all the way from paranoia to like, who cares? Okay, so we have to pick some point, which I think is as much feasibility, design, simplicity driven as, you know, how far on the paranoia scale do we want to get? All right. What's still out? It's the last one of this one, which I almost didn't overrun. Lots of explanation sections. So the desire came to really explain how much of the spec do you have to implement on the leaf, on the spine, on the very top of the fabric. So we have to write that, right? Just to tell an implementer, you know, this is the slice. And, you know, the complexity raising with the higher you get up in the fabric, which is exactly the desired, you know, outcome. Then the east-west super spine, like I already alluded, where the direction of the east-west link actually changes to run the fabric, which is mildly confusing originally. That needs to be more explained. We have the spec, but the spec is just the spec. It tells you what to do, but not necessarily why to do that. Security envelope, soft token generation, all mild stuff. Whoever's interested in that, join the weekly, grab us. Fascinating discussions, Greenfield, right? And you don't have to take your mom, you're actually involved in Rift. Okay. I'll talk about the interesting oscillation we found, and that's a discussion. Yeah, I'll explain the oscillation we found on the lies. Actually, that Bruno, by sheer misconfiguration, found, which is exactly intended. And then there is a delicate case on the tide reception, join the weekly. That is caused by very sophisticated sequence of reboots of nodes in the fabric. People have to reboot in just the right sequence, and then you may end up stuck with in the north with a tie, which can be relative. We have a good proposal how to clean it up, but that's basically still needs to be spec'd out, which will give actually in the flooding rules the only case where you have to understand whether you're going north or south beside the scopes. Negative disaggregation, Pascal will talk about it. We need a section on that, and that's just information rules. They should be moved out of the FSM descriptive text into the appendix. I find the whole, here's a story, and then here's the real spec in the appendix for the implementer actually quite helpful for the whole thing. All right, that's it. It's an update. Comments, questions? Yes, boss.
Alvaro Routing So I'm very happy that you guys are making progress. I'm really happy that you're picking up interest from other people that were not originally working on this with you. I'm also happy that you guys are recording the meetings that you've said several times just in the last 2 minutes that other people could join the weekly meeting, all that stuff. I don't want to make this too heavy. It would be great that when you send out the recordings, for example, I don't know how many people listen to the recordings. How many people have listened to the recordings of those meetings?
Yeah, a few. I assume there'll be 2, 3 of the core guys who are missing it. This is dense stuff. Yeah.
Right. So exactly no one, correct. Or one person, sorry. So it would be great that when you send that out, if you put a little summary, hey, this week we talked about blah. And I know that in some cases you have said this week's call on flooding.
Yeah.
In most cases, you just said, here's the recording from today.
Sure. Small effort.
Yeah, at least if in that case, if I know what you talked about, maybe I care more and I can go listen.
Fair enough. Fair enough.
And just like any group of authors in any draft, you're free to go meet whenever you want and do whatever you want. If you're going to send the recordings out, it would be great if it's just a little summary, right? Not paragraphs of stuff, just some bullets.
Yeah, easy, because mostly it's quite a linear progress. Okay, so we weren't like jumping. Maybe there will be 2 topics coming up max, right? And that's actually easily done. So people can track progress without actually even listening. Yeah, that's true. Yeah, but thanks. Yeah, good suggestion. All right.
Slides for 15 minutes.
Right, so no problem. Almost a movie. All right, so I think this is the place where he starts, and this is the mountain he aspires to fall down from. That's Bruno's update, right? So I think it's one of these things he goes about, look for trouble. So Bruno's not here. He gave me this stuff, and this is pretty much the output of the open source work, which he frames in his own way. All right. Good. So the usual marketing blurb, what the stuff is. So originally we wanted just to test the LiFSM. Yeah, it's, things take their own dynamics. It looks like, I hope, we'll have basically a server implementation out there for free. Good. So basically, Bruno is really kicking my rear behind to get this, all this spec to his standards, which are excruciating as they should. And it should be the reference. It really is. And actually, I'm using it even farther. I'm telling people, if you want to learn how the link state works, this is probably the place that you want to go. And I show you some of the output, which otherwise are very, very hard to get, except proprietary development tools within corporations that are not too interested in exposing any of the stuff for obvious reasons. All right. So he's building a framework which is very heavy on testing, debuggability, visualization, this kind of stuff. Performance will be lousy, but it literally is irrelevant when you look down at at the requirements on the host. It's just default route for all practical purposes. Python, he's very what you call it? He likes his documentation, as he should. Not associated with any vendor, maybe yet. All right. So here's how you get into that stuff. Here's a nice page, and you can install the stuff and start up. So you basically pull up some Python thing, get a virtual environment, the usual Python stuff, 3-4 libraries which you just pulled automatically, and you're in the business. All right, where is the stuff? So adjacencies, 75, yeah, something like that, 80. I don't even know what he's missing. So the hello has been banked on for quite a long time. The ZTP has been pretty much completely banked out. He was a disbeliever, as he should, so he built all kind of weird miswiring cases and so on. All seems to come up as intended. No routing computation has been done yet. If it's a host version, it's trivial. It's basically go one level up and grab your TORs pretty much, unless you do bandwidth adjusted, which is a little bit more work. And management interface, I don't know what he means by about half done, but I show you what he has. Development tool chain, not even clear what that is. No automated testing, continuous integration, all the stuff is in place since a long time. All right, so adjacencies. Oh, I see why he's unhappy. So we have all the lie packets, final state machine. We interrupt the stuff through a whole slew of like, you send me weird stuff. We went through the whole thing. Really, 80 to 90% of the heavy lifting, like misformatted packets, is not there, right? Because then you can even desert the model. So that saves all the serialization, deserialization. There's no code. It's all generated. So at the end, you just look at, did I get information that makes sense? Nothing else. What he doesn't have is the IPv6 adjacencies. As everybody knows, IPv6 is a hoot to work with, especially when you get into multicast socket interfaces, as I warned him. So he didn't get to that yet. Options are around, but it works utterly different than IPv4 multicast and sockets, just because. We'll talk about the Malta neighbor stat. He doesn't have any interactions with BFD, which on the server side is an interesting kind of sidetrack discussion. I actually don't think the server should be doing any BFD, should be just used in a mirrored mode when you bounce it off BFD. Join some deep call, we'll talk about the stuff. And security, because that's what we chew on, right? The security envelope, the nonce exchange, what do we SHA, do we do shared key, public, private key? It will all shake out. Zero touch, pretty much everything done. We interrupt, weird stuff, all done. Flooding. So the flooding is about, I would say halfway there. No, flooding is actually like 80% there. So we do all these packets, different ties and nodes, prefixes, databases, all the queues, procedures, whatever. We interrupt the stuff, finding all this interesting stuff. I'll be talking about some of that. Code, of course, sucks, right? So it just always deserts, sirs, and so on. The size we're doing the stuff for server implementation, pretty much of no relevance. He doesn't do positive disaggregation ties, which means nothing because those are basically normal prefixes in a different tie. The negatives we don't have spec'd out yet. Well, we have them spec'd out, but we don't have the implementation either because it's all under discussion. Pascal will talk. He doesn't do key values. We have external prefixes, doesn't do that stuff. PGP, overload, and the clock comparison, which is a cool thing. It's not much work, but it's pretty cool because if you have a clock on the fabric, it will give you perfect protection against people actually mucking around, compromising sources, reissuing stuff, or stuff that is still in the fabric. All right. Route calculation, he didn't do anything yet for the server. We'll need to do the northbound. And yeah, so for the leaf, we don't need any of that stuff. So we see where the travels take us. We start probably from the host, from the server, which is kind of the natural growth, up the fabric. Management, CLI, boring stuff, sorry. So actually we aligned on the YAML format, how we describe topologies to run tests very quickly. It's very convenient. He can take my stuff, I can take his stuff, and we can run the same file, and half of the stuff is his, half of the stuff is mine, or whatever. We mix and match implementations, and then we can look at the stuff through kind of a standardized interface. Do we get what we need? Configuration, comment history, stuff like that. He wants an SSH client, we don't have it. Yang data models are kind of early. Development toolchain, yeah, 90% code coverage is a drama. And Bruno thinks about writing a Wireshark dissector for Rift. It's kind of a natural one, I like that. And actually Wireshark supports now a very sophisticated plugin interface. So you don't actually even have to hack Wireshark, you can write plugins. That's something that's on his mind. Because right now, in flight, we don't decode packets. We just look on both ends. Do we get what we need? Everything's fully automated, and then some. Travis, piloting. So Bruno also has a very nice final state machine framework and visualization tools. We'll see some of that. Okay, so what did we find? I know, I still have tons of time. We found a multi-neighbor oscillation. So when you end up, we say it's a point-to-point link, right? And that's about it. Now, if you misconfigure and bunch 3 or 4 people, funky stuff happens. And we thought yeah, no big deal. It turned out that because of all these cool optimizations to bring up adjacency real fast, bad stuff was happening. So we had to back off. So that is caused by what he calls triggered loops. So the packet formats can actually, the packet sending are basically building up the oscillation. You will see the graphs. And we have to introduce a new multi-neighbor state, which is not much of work. Don't fatigue was starting on it. We basically have to cool down when we see multiple nodes, on the same link, more than 2, and give some alarm or something. Or we extend the protocol to ethers. But since there is no demand, it's kind of, futile at the moment. Flooding oscillation. Okay, so we found flooding oscillation, which was nothing major, but just, annoying and really poke the finger into the loose language. It wasn't even a bug, it was really loose language. Okay, I show you the stuff. So we had to tighten up the language of the flooding scope. It wasn't clear who was filtering. Can you send what you're not supposed? The other guy should suppress it, or you always must filter. And I was, sloppy as I am, I was sending a little bit too much, like can't hurt, right? And he wasn't filtering. And the next thing, we had an oscillation. All right, minor issues. All right, so multi-neighbor scenario, simple. We're supposed to be a point-to-point, as all the, respecting fabrics are this day. Modulo maybe some, discussions I'm having with people, but then the whole bandwidth management becomes impossible. What does it mean I put you on an ether and there's 20 people on it? Who gets what, right? So could happen by accident. So what happens to the protocol? Well, that's what happens to the protocol. He looked at the Wireshark and bang, we just filled the wire. For every those people who didn't get it, not a desirable outcome. Okay, but it was fun. So Bruno accused me of a bug. I accused him of a bug. Fantastic. We found that actually this fully intended behavior. Okay, right. All right. And here you see one of his first tools. So he's generating all this beautiful SVG that you can visualize in time, and you can flip on things and just focus on a certain flow and so on, just because he got desperate, which I think is a great, motivation. So that's what it looked like, right? People started to send, so those are the 3 people, and they start to send to each other hellos, and this thing starts to trigger, and they get a beautiful bifurcation. If you know anything about chaos theory, you could teach it right here. So explanation was like that. If you are a neighbor and you are in two-way, which means you heard from someone, but you didn't tell them, you were hit by 2 people, and Y and the Z as an X, who told you, you said like, okay, I'm in two-way. Now the two-way was really eager, like I want the 3-way from you, which was immediately pushing out a hello. Yeah, I know, but it helps. So that immediately created 2 packets on the multicast to those 2 people who all received them, were very eager to become immediately 3-way with you. So, multiplying by 2 is a pretty powerful tool. All the other stuff, not that relevant. So we ended up with exponential growth in number of line messages. And the FSM was oscillating as fast as it could, right? Just everybody was just doubling the packets, and everybody was very eager to send out 2 packets to get to do 3-way to these people. Well, that's how things goes. So we need to basically new multi-neighbor state, which means that if I'm in a 2-way and I'm getting hit by so if I'm an X and I get something from Y and I get into 2-way and I push thing out towards him like, hey, here's the 3-way, I reflect you, but then I get hit by something from Z, then I have to say, nah, I'm in a multi-neighbor state. And we basically cool down for whatever it is, second 2, all right, and probably have to raise an alarm, saying like misconfigured. Don't do that. Next one was a flooding oscillation, mildly more interesting, nothing amplifying. So this was an amplifying oscillation caused by the fact that we were very eager by arrival of packets to trigger events of the FSM, instead of just waiting for a timer like, okay, I heard from you in a second, you'll hear from me, which is wanted to be really fast. So this is far less dramatic. We were seeing a tide, which caused a tie. So CSNP sending an LSP and PSNP for people defective in the language, talking like ISIS is 20 years old. And that was going on. On every tide, we saw this tie and an egg, and then against the tie, and the guy asked, was sending the same tie. So like nothing dramatic, but uglish. So we went looking, and it was again caused by my loose language. I didn't say who is supposed to filter, and do you send only this much information on the tide, or can you send more? And if I send more, is the receiver supposed to filter, or is he supposed to send? Right? I was just like sloppy. IS flooding is so stable, you really have to do stupid stuff. So in more detail, it was going like that. The tide was pushing something. Yeah, forget. So the tide was pushing something describing. Why was that? Oh, so the tide was pushing something which is really out of this flooding scope. And this guy would be pushing the tide because he saw like, oh, you know, you requested stuff. And this guy will be acknowledging that, but acknowledging would have been dropped as far as I remember it because it was filtered. So next time the same, so this tide was actually not accepted because it was like, hey, you are giving me something out of flooding scope. He described something out of a flooding scope. This guy was pushing this thing out of flooding scope. He got an ACK, but this thing never got accepted in database because it was out of flooding scope. Yeah. So like we had to specify like who is filtering. Do you double filter? Are you allowed to send more? Those are the weekly calls, which are fascinating because a lot of the stuff burns down to like, what are the data structure? What's efficient, right? I mean, when I build those tides, can I cache them? Do I filter them? What's the cost of filtering them? Who can do cheaper filtering? This is how you build those beasts, right? 2 minutes, yeah, perfect. And the flooding oscillation 2, I absolutely do not remember. I just looked at it. What did he cook up there? Okay, so we send a tide, we announce a tide header. North, you know, one is probably node, which node tie, and some sequence numbers. And this node 2 was sending a tire. Oh, because it didn't have this tide. Oh yeah, that was the other installation. So now we are sending this stuff, and this guy requests it, but we are filtering on the output. Like, you are not supposed to ask me for this tide. Yeah, I send you this information, but you're not supposed to ask me, so I won't send you that. So he keeps on asking. Right, so who's filtering? Am I allowed to ask? Then, or you shouldn't have sent it in the first place because then I keep on asking, or yeah, I can send you, but you're not supposed to ask. So these are like, you know, tied language and descriptions. All right. So the flooding scope rules, so lessons learned, that's the interesting stuff. And I still have 15 minutes. So the flooding scope rules are obviously sensitive. We all know flooding is delicate, right? That's where people hack BGP. Just less potential to hang yourself up. When flooding works, it's like the most beautiful distribution, you know, loose synchronization path in the world, but it is delicate. And we have flooding scopes, as do the traditional linked protocols grow. Right? I mean, we're talking here all northbound flooding. Southbound flooding is trivial. It's just one hop rip with default route, pretty much. So tiny change in rules can lead to oscillation. Nothing amplifying as it looks, but you know, you'll oscillate persistently. Not elegant. But the positive stability is intoxicating. We were playing it loose and we never melted it. So the rules for the flood, what you flood out, what you show, and what you ask, they must be consistent. Okay, which is not trivial because they are not orthogonal. They are basically joined at the hip. So Bruno had some ideas how to maybe write and represent the whole flooding scopes differently. First iteration didn't lead to much, but this is not a simple problem. Some kind of representation where this at hip disjointness will become welded, maybe some model, or otherwise, you know, very hard to fracture in a sense. Yeah, so he was thinking about maybe putting the flooding scope in the tie header, which I think is a solution from hell, because if I'm getting this tie on a flooding scope and I'm supposed to, or maybe it shows me a flooding scope this thing is never supposed to show up on, you have like the presence of these things bellies its scope, while what it tells you about its scope contradicts where it is. So would you do that? More details, there's some Prezo and some graphs and so on, you know, nicely documented, cool. So we ran like I said, we run in the vendor stuff, one process, Python, another process. We pull in one topology file, which describes the topology. And by very simple mechanism, you can decide who gets what. all fully automated. You run this thing, pull out state from both through different means, and see whether you got what you needed. Flooding is not automated yet, and the rest is all fully automated. All right, yeah, it helped. Lots of editorial, small things, protocol. Do interoperability tests at an early stage, which means implement an early stage. We knew that since 25 years, we're forgetting that. Visualization tool, yeah, but of course it takes time to build. SVG helps. The SVG is a great thing. It saves you tons of, like building the visualization out of the format. Yeah, the calls are cool. 1 hour a week, you learn by osmosis, and you can, everyone's welcome. Yeah, so more people to hack the stuff is fine. Bruno has, levy walls. You won't even be able to ask him for a pull-up unless you meet the stringent, coverage and whatever not testing requirements, which is cool. Allows us to keep people out who will break stuff. I think that's it.
I want to add that if you are into protocol development or implementation, working in this team is really, really beneficial.
Yeah, so we're the, what do you call this thing? Not purveyors. Yeah, we're the purveyors of a art that's getting lost. All right.
Well, I don't know if I will need this. Okay, so just to recap, when we build those fabrics, what we want to get is that each leaf can talk to each spine. So you can always reflect something which comes in the leaf, at least at the top here and to somewhere else. And what we call a fallen leaf is basically when whatever is in the middle, there is a loss of connectivity between any of those guys and any of those guys. And basically we call this guy a fallen leaf. That's pretty much our definition for it. And in version 3, we have added some text that might go away. I don't know. I mean, it's just to help people understand. What do we have a bar on top? It's kind of removing some text. Well, it can go away. Well, it doesn't matter too much. So we have added text that explains, when you get this breakage, do you need to disaggregate? When you get this breakage, do you need to disaggregate? It's more like, so you understand how we build the fabric and you understand what are the consequences of losing this thing versus losing that thing. And the disaggregation is really the process that you have to do from the top to actually say, hey, don't use me because I can't reach its final leaf. It's fallen for me, so don't use me. And you have two ways of doing that. You have the positive disaggregation, and now we have the negative disaggregation. So the positive disaggregation is flooded by all the guys who can still reach the leaf so as to install a route via them as a more specific route to the lost prefix. The problem with that is it's a lot of flooding because it comes from all the superspine nodes which can still reach the guy. And the idea of flooding that recursively down the graph is kind of big. So we looked at it, we looked at the corner cases, we went through a lot of exercises with Tony and a lot of possible weird topologies. And we end up saying, hey, let's do what the draft always said, which is it's not transitive, it follows the source flooding scope, which is one hop. And this also has consequences. So we went through those discussions, and then we said, hey, if we want to go transitively, there are rare cases like Tony said, which is probably not the case when you don't partition the superspine. But if you do partition the superspine, like I did here at the top of fabric, then you will end up in cases where you have to transitively go down all the way down the leaves. So the leaves here are represented. They are these guys. And you see I colored the two topologies, the two planes. And you realize that the leaf is the guy, when he injects a packet in this fabric, is the guy who makes the decision in which plane the packet is going to go through. Right, and if this guy, if the leaf decides to go through a plane in which the leaf is fallen, then the packet is doomed. But only the leaf makes that decision. After that, the packet is kind of read all the way through to the destination. So this partition superspine is the case where what's described in the document as positive disaggregation cannot work because the superspine in different planes don't see one another. And so you have to go down all the way to the leaves to tell them, hey, don't use plain red or don't use plain blue. It's pretty much that. And so we figured that the positive was just too expensive to do recursively and flood all the way down. So we went through this other option, which was to do the negative way, which is to say, instead of having everybody who can still reach this guy, transitively say, I can still reach this guy, it's more like the superspine node who cannot reach this guy, just say, hey, I cannot reach this guy, which is a lot less operation. And as it goes, doing the transitivity, and we'll see later, doing the putting it down all the way to the leaf in any topology actually is much simpler than doing the operation on positive. So we'll go through what that operation is and what goes on. So like I said, there is ample text like this, and we'll go through 4 slides which are like that, which tell you, hey, depending on the case, you will need to disaggregate or you won't need to disaggregate. And I think this text is useful as it's there to understand really the consequences of things. Will that text stay in the final RFC? I don't know. Or, well, you all decide. It doesn't give you anything that you have to do. It helps you understand why you have to do it. So basically what and they put the text in line. I pretty much wrote in this slide what I wrote in the spec so that you can see really what it deals about. And basically what that tells you is in any of those breakages, you know, this link down below the leaf, this link, this leaf node, or this superspine node, when they're broken for everybody. So they don't create a special case in one plane. So there is nothing special to disaggregate. The normal routing does the stuff for you. For instance, if this guy here dies, nobody will use him. So it's not a disaggregation problem. Same thing if this leaf goes away, it goes away in every plane. So there is nothing special to do in one plane like a disaggregation, right? So all those classes of problems don't need disaggregation. The text won't say, if you're in this case, you don't disaggregate, right? You can't mess something like that. It's just to explain you in which circumstance it happens and in which it does not. Oops. It's the full screen game, right? You need to press it here. Okay, so I would say the normal case, which is always the case when you don't partition the superspine, is that a breakage which happens in your plane can be detected via the southern reflection within the same plane by the guys who are just above the breakage, right? So the breakage happens here. The guys above the breakage see one another inside the plane. They can do the reflection. S4 figures that S2 cannot reach the red plane. It will positively disaggregate, and that's enough to make sure that all the red traffic will go through S4. So the positive disaggregation in a case like this fully solves the problem. Okay, so and then again, it's the normal case when you only have red guys. Whichever loses his link here, it's completely solved within the plane. Okay, so that's kind of an easy case where the spec without the negative disaggregation already solves the situation. Now, sadly, there are other cases, and one of the other cases, if the breakage is in this link as opposed to this link. In this link, the southern reflection will happen between those two guys, so the situation is locally solved by the non-transitive positive disaggregation within this particular pod. You could observe it on the parent on both sides, right? But it cannot be observed by the southern reflection of just the TIEs here. Well, it could, but then those guys would not be able to go all the way down the leaves to tell them, hey, you need to pick the other plane, because the positive disaggregation is not transitive. Right? So there's no way with the positive disaggregation to discover something here and then go all the way down to inform the leaves, hey, don't use plain red. So the positive works within the pod, but is ineffective outside the pod. When we do negative, the parents here above the breakage, so that will be this guy, could do a negative to all the red plane and say, don't use me. The problem is, if it never saw what's behind L2, it doesn't know which prefix to disaggregate. Okay, so it can know there is a problem, but it cannot know for sure what the problem is. It cannot know. So if the fabric came up and all the prefixes were advertised, etc., magnificent world, then you would know which prefixes were reachable through this link, and you would be able to disaggregate them. But if for some reason he was never aware that something came up here, or if something comes after the breakage, he cannot know. All the blue guys will know, but the red guys won't. Because the flooding is cut, so you don't know what's behind. So you're in this situation where the red guys know that there is a loss, but they don't know what it is. The blue guys know what prefixes are associated to this lost link, but they can't tell the red guys. That's why we'll go through those rings that Tony has represented. And here is a more broken situation, but it's pretty much the same logic in the end. If you lose this, we call it spine or top of pod in this case, node, then yes, you cannot go to any of those leaves in the red plane. And the same thing applies. This guy knows there is a breakage, doesn't know which prefixes are affected. These guys know that something is affected, but they can't tell exactly what it is to those guys because there is no reflection between those two planes. So that's where we are. So to solve this problem, one suggestion we have in the draft is actually to enable to ring 2 by 2 actually the pairs that can be many by many. If in the representation that we have in the draft, it's actually maybe clearer this way. So you actually ring all the guys in kind of the same line. By ringing them together, you recreate a bigger switch in a non-partition world. See, if those guys were a single guy and those guys were a single guy, you would have a fabric that is not partitioned. So we recreate that, and that enables these guys, the red guy who discovers the breakage, to get the list of prefixes that are broken from the other one. I know there is a breakage behind me. I don't know what prefixes are lost. I know what prefixes that mean I can tell you. So on this link here, actually, we will advertise prefix ties, prefix ties. So we know if you have a breakage, what that means. Okay, so that's pretty much how we can do this game. One could also design a super spine up there so that this information is actually shared by both. That could be an alternate way of doing it. And with this, we'll go into the details on how you do the negative disaggregation. So remember, we are in distance vector space. So it's a bit different from what you may see. Some people are doing that, naming is doing that in I guess, well, there is a draft which attempts to do that in the ISIS space. But here, we are in distance vector world. And you'll see that makes actually life much, much easier than it would be if you do any form of flooding, because it's a one hop. The flooding scope is basically one hop. So you can really make a decision at each hop about what you already got, and we'll see how that happens. The whole principle of negative is that if there is a breakage, like this is a fallen leaf, I don't need to tell you what's behind, but we lost the connectivity between this particular leaf, if you like, and this particular type of fabric. Or it could be just a link, or it could be just the logical visualization that I had in my very first slide. Whatever connectivity is here, the connectivity between this guy and this guy, this final leaf is lost. Okay, and if you're in this situation, with the negative, it's going to be S1, which lost the connectivity to prefix A, that will inject to all its remaining children in its own plane, that it lost the connectivity to A. So it kind of injects a rot to non-A, right? That's how I represent it here. And the reaction by any of these children, and here I picked M1, but it's going to be the same for M2, M3, is that they will, in the forwarding routing table, so we don't, in the spec, we don't say how a fib is built, right? Everybody's free to build his own fib, but in the forwarding, oops, wrong button. In the forwarding plane, what you really end up doing is, if you receive a non-A from one parent, one of the guys at the level above, you really install a route to A via all the other parents. So basically this one message is equivalent to getting at the very same time, and that's kind of interesting, at the very same time as many messages as you have other parents. So when you apply this, then the load balancing that you could have with all the other parents is still maintained. It's kind of an interesting property. If you got a single positive from one of them and then later a positive from him and then later a positive from him, the result is during a small period of time, all the traffic to prefix A is funneled through the first parent, which sends you the positive disaggregation. Something that's kind of, so you have this transient state with the positive that makes it so that you get an incast in this particular node, which is good to remember. Okay, so with the negative, you don't have this particular incast, you just divide the traffic with all the other parents. Now, if we continue on this, if actually the breakage is more extensive than what you thought, right? This other parent cannot see the same prefix. For instance, these are those two links which are broken, but could be any sort of situation. It will also send a non-A, right? And the reaction of the second non-A is to go through the state that you already have in your forwarding table and say, oh, I have to remove this one because now it's no more valid. And that's it. That's all you have to do. So one cause, one action, I'm done. Which is pretty cool. If you were looking at doing that in positive world, you'll see it's much more complex. And you would need actually information that you don't necessarily have to know if you need to do something or not. Because you would depend on what your neighbors do. It's weird. So there we go. On the second negative advertisement from a second parent, I just remove an entry that I just created. And we continue, and when we reach the last parent, this is when it becomes interesting, the way the thing transitively percolates down one level. The time you receive the non-A from your last parent is the moment that you discover that A, you cannot reach A either because none of your parents can. And obviously, it includes the fact that you don't have a southern route to A, obviously. So you end up with the knowledge that you don't have any route to A, which boils down to the fact that you need to tell your children, all of your children recursively, that's when the process recurses. You tell brutally all your children, hey, don't use me. And they will start using all their other possible parents. See? So you get a negative, you use all the other parents. If you get negative from all your parents, that's when you trigger your children. It's pretty much as simple as that. And you see that in a distant vector world, when you just get things parent by parent, it's very easy to create this logic. Same thing happens the other way around, right? If the connectivity is restored, I wrote it receive A, but it's really a non-A, right? You receive the undoing of the non-A from a first parent. As soon as you receive the undoing from the of the non-A from a first parent, it means, hey, you can reach A via this parent, right? So it is the time where you tell all your children, hey, I'm back, I can use A. At least I have one path to it, which could create an incast, by the way. And as you keep receiving more and more non-A's from all your parents, you reinstall those entries that you had just removed as you got them out. When you install the last, that's when you consider removing well, we'll see in the rib what happens, but the entry gets away from the rib, and you can remove all the fibs altogether. Because they tell you that the route above, which is the aggregation, is actually aggregating everything you could do with the aggregated route. So the time where you get from the last parent is the time when you consider removing everything. Okay, so that's basically the function, the operation, and it's as simple as this. Now, I represent it here. It cannot be in the spec because we don't talk about fib, but I represented kind of an abstract way of doing the rib, and then kind of an abstract way of looking at the fib that goes with it, just for the sake of visualizing what happens in the forwarding plane. So if we have this default route, which is all my parents, S1, S2, S3, S4, and now I get one parent, like say it's S1, which tells me, hey, there is this prefix, which is like aggregated by default right now. It's a /16, and I'm getting a non-A for via S1. So what I end up doing is I had a fib which told me default only. It was like that. Now I create this fib entry, the more specific to this /16 prefix, and I look at what was above, what I inherited from, what my parents, what I could do without this non-A, so what is above in this table here, and I just subtract. I copy it and I subtract what I cannot reach. So the result is this minus that gives me this. Okay, so this is what I inherit from. This is what the result of the inheritance by removing this. That's really the operation that you have to do. Then, if there is another prefix which also inherits from default, right? There are prefixes at the same level in my table, and this one says, oh, it's via S4 that I cannot reach. Well, this one inherited from this. This one also inherits from this, right? So in this case, I subtract S4 from what I inherit from, which is the parent in the RIP. Okay, so far, kind of not too much surprise. A little bit more surprise is what happens is in default, I lose S2 globally. S2 is dead, my link to S2 is dead. Well, all those things, not only the fib here, which was associated to this ribbon tree here, but also all the inherited prefix, remember? They were inherited from him, they depend on him. If he goes, those can't stay. So you have to look at the negative inherited prefix that you installed because of this inheritance, and you have to remove them. Okay, it's like, remember, a negative is like multiple messages in one. And now we look at a maybe more curious case and probably a less realistic, but imagine that you subnet and you get negative within negative, which is kind of weird. If you ask me when that can happen, I can make you a drawing, but it's a really, really weird drawing. If you do this very weird drawing, you've got a /16 and then a /24 within that /16. And guess what? You get a negative on the 16 and then on the 24 as well. So from the 16, I installed the 16 and I said, well, this minus that gives me this. Right? Well, this really minus that gives me this. Now, this guy is the parent of this guy, right? In this hierarchy here. This one is a subnet of this. So the capability to reach 10.0.10 before I got this negative was the capability to reach this, which means that it was through those guys. That's what I'm inheriting from. So now if I get a non-S2 for this sub-prefix of this guy, I have to subtract it from this, not from this, because this is my parent. So the result is that. Right? Then same story again, if I lose this guy from which all this is inherited, well, not only do you lose it from here, but you have to recursively go through here, and then you have to recursively go through here. So you have to look up down the tree of inheritance, which in the real world is not expected to be anything more than one hop. But you could devise weird games where you would actually have to go deeper down. Now, there is this rule in Rift. You could get a positive route and a negative route for the same prefix from different people. So they appear in that table, in that trip here, like in the same place. You've got different types of routes. Like you could have a southern route and a northern route, and you've got priority rules in Rift, which tells you, hey, you always favor a route going south over a route going north, even if it's about the same prefix. In the same logic, we made this decision, and it's actually, it was an interesting discussion. There are pros and cons here. So that the positive route wins over the negative route. And the consequence of that is if you have a positive here somewhere for that prefix as well, actually all those negative routes go away, only the positive stays, meaning that there is no recursion. Because those negative are only installed if there is no positive for the same prefix. So normally when you're at the same level, so you're one hop away from the discovery, you get the southern reflection, you get the positive. Well, and if the fabric is not broken, it's not partitioned, that's exactly what you'll get. You'll get a positive and you'll get a negative. You'll prioritize in your fib the positive, meaning that, again, this entry will not exist. So we did not consider that this recursion, which could, in theory, be heavy, would realistically be heavy, right? So the idea is the most probable case is you get something minus something, and that's going to be it. And last slide, I color differently the forwarding table depending on what type of ribbon tree was used to build it. So as the result, if you look at this, the normal flooding gives me southern routes. So the route to A is installed via S3, S4, and M4 to L4. So that's how I can get to A with normal flooding. That's basically the shadow cone of A in that case. That's what I can see when I flood, knowing that this link here is expected to be broken. Now, because of the southern reflection here, well, actually, because this is broken, so it rehappens here, M4 is aware that A is broken for L3, right? This link is gone down. So M4 will positively disaggregate one hop. So this route here is the result of a positive disaggregation. And now, due to the negative disaggregation, S1 and S2, because now you see S1 and S2, they cannot see A anymore. They will do this recursive operation. E will disaggregate negatively, E will disaggregate negatively, meaning that E will disaggregate negatively. Same thing for S2. E will disaggregate negatively, E will disaggregate negatively. So, but here, since there is still, well, here you would also have a green, but since the positive wins over the green, that's why you don't see the green. Otherwise, you would have the green route here too. And check. Pretty much through it. And I said that this one is also in Tiebreaking Algorithm. Well, I need to rerun that in my mind. Oh, it's because those are the RIB entries and these are the FIB entries. That's what you have to reread my slides. But the RIB entry follows, the propagation of the negative. The FIB entry is what's left. So the forwarding is really along the red, so that I can get into one of those two which can route. And the green is really the RIB entries, not the FIB entry. So that's what's interesting, right? As long as you do positive advertisement, the RIB and the FIB, they tell you the same thing. But when you advertise negatively, which is the other way of the green arrows, which are really the RIB entries, the FIB is whatever is left. So the FIB is this guy and this guy, where the RIB is this guy, this guy, this guy, this guy. So in FIB, I really don't have many states, which is interesting to remark. My FIB is very minimum, and it points exactly to where I want to go. So you follow the red and yellow arrows, and this one as well, and you always go to A. And you've solved your routing problem. And that's pretty much it. Do we have questions?
Hey, Zealand of Cisco Systems. I want to make sure everybody's ready for the pop quiz following this.
Sorry?
The pop quiz.
In French? Very useful sometimes. No, but pop quiz?
J'ai oublié.
Oh, good. But is there a question? Because I really don't understand. And it's no joke. Okay.
I was saying there'd be a test. Whether people understood what you told them.
Okay. Did you understand what I told you?
Yes. So just to clarify, is this only needed when you have multiplane, or?
We don't. Yes, it's true, but we don't say that. We just say do it. Now, some people who want to save on their implementation and they know they are not going to do multiplane, yes, they probably can save that code. Because, yes, it's only when the southern reflection on the super spine here on the TOF doesn't work. And as long as all the TOF guys can see one another, they will always learn what they want to know. The problem of not knowing which prefix I lose, etc., and not being able to actually go deep enough is because those guys don't see one another and they can't clear. I call it a ceiling, right? But it's basically mean if I see everybody and I can touch all the level below, then I can install a clear line at the level below which bars everything wrong, like a ceiling. So nothing can happen without this ceiling intercepting the packet and sending it to the right super spine. But if it's partitioned, then you cannot install a full ceiling right below the super spine, so some packet may go to the black hole. So yes, it's visualization of it.
Okay. Thanks. We need to move on now. So Dave is going to share his thoughts on flood reduction here, and we could have some interesting discussions. We have 9 minutes in total for the presentation and discussion.
So X marks the spot here. Excellent, thank you. Okay, yeah, I thought this might be of interest to this group, so I asked for a little bit of agenda time to present it. And it basically it's what it says on the tin, a distributed algorithm for the constrained flooding of IGP advertisements. I submitted the draft into this IETF. It is about the general problem that was discussed in draft Lee and LSR, and has also brought forward a plethora of discussion and solutions for how to produce a constrained flooding topology in a dense graph, with some of the requirements being that it would be immune to single failures, but the key thing was it would reduce the number of copies of an LSA that would be continually interrupting the control plane for any given node in the system. So this is a proposal that's based on things I did in a past life, and it discusses and it puts it forward as a distributed algorithm for computing a flooding topology, and it has quite desirable properties with respect to bipartite style dense graphs, modified bipartite graphs with intertiered links. It may be applicable to other topologies. I could probably elucidate the requirements for those topologies to use it, but that would be for further study. The actual approach is your starting point is to use two diversely routed spanning trees constructed such that each node in the dense graph ends up being bi-connected to the flooding topology. Each node computes the spanning trees knowing the roots and then determines its role in it with respect to how it's going to treat LSAs. And this is based on information obtained from the IGP. And the flooding topology itself is the sum of the spanning trees. So the first copy of an LSA received by a node, for example, is the one that's propagated further on both trees, regardless of how it arrived. So it's a first past the gate sort of solution. The actual flooding itself is split horizon between the upstream and the downstream for LSAs that are received from an upstream interface. So if I received one coming downstream from the root of one spanning tree, I'm not going to reflect it back upstream. That would effectively be about the closest thing to a loop you could produce. The net result is in a fault-free network, all nodes that participate in the flooding topology will receive two copies of a flooded LSA. And in any single fault, they will get typically two. One or two of them may only get one. It depends on whether the fault actually impacts the flooding topology itself. Now, what makes this work is the tie-breaking algorithm for constructing the spanning trees. This is lifted from 802.1AQ, shortest path bridging, which applied ISIS to the routing of Ethernet networks. This in particular was for shortest path bridging MAC mode. The actual algorithm and an example of using it with ISIS is documented in RFC 6329. That's also available in at least one or more commercial stacks that I know of. And of course, 802.1AQ itself is deployed in about 1,000 networks that I've heard about. The actual tie-breaking algorithm uses a lexicographically sorted list of the node IDs to tie-break when multiple equal cost paths are found. In essence, you construct a path ID for each path, sort them, and then you can rank them. Now, one of the interesting things you can do with this is prior to ranking them, you can also use what's known as an algorithm mask if you want to produce more than one diverse path. And you XOR the node ID list with the algorithm mask prior to ranking. And if you use an algorithm mask of 0 or FFFFF, effectively what you can do is use the bookends of diversity. So each tree in this example is constructed using one of the two algorithm masks, and the trees themselves are both link and node diverse. The net result of this is for each set of nodes that's equidistant from the root, The low and the high node IDs are selected, the low node ID for one tree, high node ID for the other tree, and this is how you actually get both the node and the link diversity. So the trees using algorithm mask 0 always will select the node ID. The trees using algorithm mask -1 will always select the high node ID. The other nice thing about this algorithm is not all order and logins are equal. One of the things you can do with this is any portion of the shortest path is also the shortest path. So while traversing the graph, you can incrementally tie break and purge an awful lot of state. This makes it quite quick and tends to explain why shortest path bridging networks converge very quickly, despite the fact they're actually doing an all pairs shortest path computation. We are not doing all pairs. We're only doing 2 Dijkstra's in this. So to give you a visual representation of the results, I have an example network here where I have the 2 spanning trees, the red and the green. The red is rooted on node 0 down at the bottom left. The green is rooted on node 55 at the top. And you'll notice that all the transit nodes for the red tree are the low node ID in any given set of nodes in the graph. And for the green, it tends to be the high ID. So this is actually how the diversity is achieved. Like I said, you're ensuring you're picking the bookends of the node IDs at any particular point in the graph. Now, the flooding rules themselves are quite straightforward. If I've received an LSA from an upstream adjacency, and it's one I haven't seen before, of course, I flood on the downstream member adjacencies and any non-participating adjacencies. One of the things Tony's draft discussed was the idea that you could have a flooding topology that, for example, was a subset of an area. So you will have nodes that are participating in the flooding adjacency and nodes that are not. And when interacting with non-participating adjacencies, you use the normal flooding rules. If I'm receiving something from a downstream adjacency, I flood it on, and again, if I haven't received it before, I flood on all non-participating adjacencies and all member adjacencies except the adjacency of arrival. And what I mean by a member adjacency is it's an adjacency that's been identified as part of the flooding topology. Now, I also use the color coding of the red and green trees to illustrate the sort of the notion that ultimately I really don't care what the tree of arrival was, simply whether it was upstream or downstream. It's the sum of the trees that we're working with. Okay. So there are some required protocol changes. We need to be able to advertise the capability to participate in the flooding topology, and somehow knowledge of the routes needs to be disseminated, or at least sufficient information to allow route election. That's an unsolved problem in this draft. I'm just sort of throwing the basic algorithm out and seeing where things go from there once the community takes a look at it. So I'm not documenting any changes or proposing any protocol elements. I'm just identifying the requirements at this point, and we'll see where it goes from here. Now, one of the things is the number of copies that needs to be generated by certain nodes, if you looked at the example, is not constrained. That was suggested as being desirable. This draft does not achieve that. I've considered possibilities of trying to partition the space by using multiple trees. So far, I don't really have anything satisfactory at the moment. So very quickly, what's in the draft? The problem space, the algorithm, the flooding rules, a discussion of the requirements for route selection, interaction with non-participants, which is pretty brain dead when you think about it, node and network startup, some thoughts on re-optimization, because of course, once you start getting failures, something may end up as incomplete, although the sum of the graphs may be complete, but you don't want to take the chance of subsequent failures eventually degrading things. And it also suggests some strategies for dealing with catastrophic multiple failures. And as I mentioned, I actually don't get into protocol details yet. So very quickly to summarize the characteristics of the solution, the structure is an interconnected set of 1+1 multi-point to multi-point trees. The protocol changes required are some means of advertising or communicating information to allow route selection, advertisement of the desire to participate in the flooding topology. The actual computation of the flooding topology is the order of 2 Dijkstra computations. The maximum diameter of the flooding topology in the fault-free worst case is twice the distance from the leaf to the spine. And the most pathological case I have been able to find is when a link between the roots fails. And so the net result is the distance between the roots -1 needs to get factored into the maximum diameter of the flooding topology. And the typical and maximum number of LSAs a node will receive would be 2. So there's a couple of things in the draft I want to update about the route selection criteria for the next version. And otherwise, I just want to collect feedback and figure it out from here. So
We're running out of time for discussions, but just sharing this here is a good starting point for interesting discussions offline on the mailing list.
okay, thank you very much.
So Sandy prepared a few slides on the update for the Yang model. I will put it up here. I don't know if you want to talk about it or not, or just because we are right at ending time now, 5:10.
Very quickly, this representation. And this presentation is for Rift Yang, and I'm Sandy Zhang from ZTE. We have co-author Yuehua, Shaowen, and Xu Sorry. Okay. The previous slide. Sorry, it's an update. Okay. Okay. This data model is defined according to Rift protocol, and this model includes protocol configuration, state, and notification. And some features are added to enhance the protocol, such as PGP and the other KV store and the other feature. And the update of this version is we change the community from Malta to list, and we reference the common policy defined in RTWG policy model draft. So it's the main update of this version. Next. This is the configuration of the Yang model. So we know that the configuration includes node info, interface, and policy, and the other things you can see from this. Okay. And this is the state of the Rift protocol, includes neighbor database and KV store. So it's the state of this Yang model, and if you have time, you can look at it. So, and this is a notification. Okay. This is remain unchanged since the last version. So.
Yeah, so things are, Tony P. Juniper, things are stable enough. I will fine tooth comb the stuff with you, as soon as I find time.
Okay.
Yeah, thanks.
Thank you.
Thanks for the work, yeah.
So we adjourn. Yeah. Blue sheets, please.